So once again, good morning. My name is Andy McLean, and I am indeed responsible for the communications business at Analog Devices. I'd like to thank you for joining today to hear a little bit about our vision for ubiquitous connectivity. And we believe this is really important. We also believe it is quite different from the type of connectivity that we have today with our cell phones and with IoT devices. We also believe that this is important on a different level. We believe that the outcomes for the planet will be in some small way impacted by what we can achieve with this vision. So once again, it's difficult to grasp the potential that we have in front of us here. We really believe that in executing this vision, we as an industry can really change the world. So why do we believe that? We believe that because we're really moving very much from the industrial age to the infotainment age or the information age. And again, whilst this is not new, we may feel as if we have been in the information age now for maybe many decades. We really see an opportunity at this point to really expand and fulfill the true potential of the information age. And again, this is more than just about creating a faster link to the cloud or to the internet. Really, the subject of my talk today is not so much about connectivity, but really combining intelligence and connectivity together to achieve a different outcome. So we really believe that this connected intelligence really defines the next major step of the information age. So just to maybe start with an example. So to draw a contrast between how we use connectivity today and the vision that we have in the future, I take a simple example. So many of you may be familiar with the application Waze, which we use to essentially get from A to B. So how do we use it today? So the first thing is you enter a destination, very simple. Waze runs their algorithms and they deliver you an optimized route to get to your destination. That route may be updated in real time. You know, it may offer you a faster way to get from A to B. And this is based on real-time conditions. And it's also based on the experience of other users. But unfortunately, as you're going through this, that can still not avoid traffic jams and congestion. So it's good, but let's contrast this with what may be possible in ubiquitous connectivity. So what would be different? So first of all of the sat-nav apps would be linked. This would not just be using information from Waze, it would be using information, say, from Google Maps, from Apple Maps, and other applications that today are not connected. The second thing is, by doing this, the intelligence can now distribute the users over different routes. So if there is only maybe a few minutes difference between the various routes, different people could be taken in different directions. In other words, we can optimize the traffic problem. Going further, traffic lights could be synchronized to these applications, which obviously it has the potential to improve the traffic flow. If we can actually make it more of an interactive feedback loop, then we can optimize the results. And then lastly, when you get to your destination, there can be smart sensors that help guide you to an available parking slot. So it may not sound substantially different, but the idea here is to switch from just having connectivity to having intelligence associated with that connectivity, giving a better outcome. So this is one example of what we mean by intelligent connectivity. So what are the outcomes that we're looking for here? So I'd like to talk about 4 different outcomes of our vision. The first one is to truly bridge the digital divide. So today we have about 5 billion people connected to broadband in some form. But unfortunately, there's almost as many, 2.9 billion people, that don't have access to the kind of connectivity that we enjoy each day. And the unfortunate part of that is that means that we're not really taking the full intelligence of the planet and applying that to everyone. So we have a disparity in education, we have a disparity in the access to healthcare and other things. So the first thing is we hope that we can bring more people into the pool that can benefit from this intelligent connectivity. The second part, and becoming increasingly important, I believe, is that this connectivity has an outcome on sustainability. So in my previous role, I was focused very much on automotive, and there it's very obvious with electric vehicles how we are impacting the planet. But with connectivity, we can also improve that. To use the same automotive example, there we are creating a circular economy with electric vehicles. The same batteries that are initially powering the vehicles will be then used to create energy at your home as a second life for that battery. So we're creating this sort of circular economy where we're not depleting the resources of the planet. We're doing it in a very sustainable manner. And there's other examples here, say, associated with maybe agriculture, where through this intelligent connectivity, we're going to be able to do a lot more smart monitoring, crop monitoring, and basically look at how we can reduce water and fertilizer. And I can give you other examples, but the point is, by having more intelligent connectivity, we can really make a bigger difference in sustainability. And I talked earlier a little bit about how we can improve people's lives with this intelligent connectivity, but this is really more about the sensing application, bringing things like biosensors into that connectivity. And again, they have obvious applications in healthcare that we haven't fully taken advantage of today. So there's other ways that we can use this intelligent connectivity to simplify and improve people's lives. And then finally, the example I gave is a good example of how we can optimize transportation. But on the industry side, using things like private networks, 5G connections inside factories can make factories more efficient, because now we're putting some of the intelligence at the edge rather than in some central domain processor or in the cloud. So these are outcomes that we are looking to achieve. Obviously, these also come with some challenges, including the pointer. There we go. So maybe what I'd like to talk about now is, how do we get to that ubiquitous connectivity? What are the challenges? What are we actually going to have to do? So it's very clear that over the last, say, 40, 50 years, we've been improving access to connectivity, and we've been improving speed. You know, in wireless, we've gone from 1G, 2G, up to 5G, and obviously many of you, I'm sure, are now working on 6G. We've also seen parallel advances in Wi-Fi. I can remember the days when, you know, Wi-Fi was measured in megabits per second, and now we're at gigabits per second. Similarly, in wired, you know, we have very high-speed connections at home and here at the Congress today, in wired connections in Ethernet and in optical connections. But again, we believe the next step is about this connected intelligence, where we're combining the information from all these data sources to get better outcomes that affect the things I mentioned earlier, the digital divide, the sustainable planet, the industrial efficiency, and just generally improving our lives. So we've identified 4 pillars that we think are necessary to achieve this vision of connected intelligence. And you see them on the screen here. These are making this intelligence available everywhere, being very open. We believe that there are some more advances needed in the true openness of this ecosystem. Pivotal to that, we believe that there has to be a lot of activity associated with trustworthiness, making or addressing the issues of privacy, addressing the issues of security, which we call trustworthiness. And then certainly last but not least, I've talked a lot about sustainability, and this is something that we also have to work on. So maybe talking about each of these in turn briefly here. Intelligence everywhere. So we've made really good advances associated with getting information to and from the cloud. That's one form of intelligence. We send data to the cloud, we process it, we get that data back. And we've seen many examples of how that has improved our lives. The next step, and it's already well underway, is taking some of that intelligence and putting it at the edge. And additionally, using machine learning and AI at the edge. So why would you want to do that, or how would you decide where to put the computing? And it's really associated with things like latency and the amount of bandwidth that is needed, and also about the privacy and security that I talked about. So maybe in simple terms, where you have to make a real-time decision, it makes more sense to put that intelligence at the edge. That is where you will get the fastest response. It will also require you, or you will have the lowest latency. For other decisions, maybe you go to the cloud. But the point is, we will be distributing the intelligence around the various ecosystems and networks that we have available to us. So, talking a little bit more about analog devices and what we're doing to enable this intelligent edge, and just breaking down this problem a little bit. We think of the problem being compartmentalized in sensing, measuring, interpreting, and connecting. So again, we're all familiar with the connectivity part of this equation, but now we have to also think about where we get the data, how we measure it, how we connect it into digital information, and then how we interpret that data and information into actions. So this is how we compartmentalize the process here. So the key thing here to note is that the data is not just delivered, which is effectively what we have today. The data is interpreted before it is connected into other parts of the system. That's really the key point here. So we talked about openness. That's a really big topic. I think most people think about it in terms of standards, how we reduce barriers to innovation. We make things standardized so that more people can actually participate in the conversation. It really has many different facets, though. It's things like flexible networks, users being able to dynamically join, participate, and leave. That's a different form of openness. What that allows is more co-innovation and collaboration. So really what we're trying to do here is, on the right-hand side here, you think, or you see the things that people think about when we talk about openness. We talk about standards, we talking about open APIs, we talk about open source. But it's more than that. It's creating an open ecosystem where people can come in, participate, and leave. So we think that there is need to broaden out the discussion over what we mean by openness. From a technical perspective, I'm sure everyone is well familiar or involved in ORAN. That's an example but it's not the only thing that we have to do in order to achieve this truly open vision. Trustworthiness. I touched on this earlier, but it's a little bit ironic that for trusted security, you need to start with zero trust. That needs to be your assumption. So if you want something to be trusted, you start with zero trust, and then you build the trustworthiness into that. And again, by trustworthiness, we mean privacy, we mean security, we mean authentication, we mean encryption. But with the number of devices approaching about 150 billion by 2030, we can't have that intelligence or that trustworthiness centralized. Again, it needs to be pushed out to the edge. And typically when you do that, when you move the security to the edge, you start to have to think more about hardware implementations. So again, we believe that for true trustworthiness, security must be rooted in silicon root of trusts that exist at the edge of the network. So again, just really a broader view of what trustworthiness really means in this open environment. And then finally, talking about sustainability, I just kind of talked about it in general terms before. Just putting some quantification on this. I think it's well known that about 1.6% of the CO2 emissions globally come from the telecoms industry, come from the industry that we work on. That's a very significant factor. And when you put it in real terms, we're talking 580 million tons of CO2 emissions last year, which is huge. And that's scheduled to grow by about 160% between now and 2030. So in this industry, we're already responsible for a significant part of the CO2 emissions, and that is only going to get worse going forward. So where is that coming from? The bulk of the CO2 emissions are actually associated with the radio unit, if we talk about it in terms of wireless terms, and specifically with the power amplifier. Now, this was addressed with 5G. 5G consumes significantly less power than previous generations. But somewhat ironically, 5G is also opening up the network and the number of users. So even though we've reduced power on a per unit basis, the number of units is exploding. So overall, the anticipation again is that by 2030, this sustainability problem increases. However, we don't believe that that is a foregone conclusion at this point. We actually believe that engineers solve hard problems and will avoid this actually being a net gain. But the goal for the industry is really to achieve this net zero target by 2030. It will be a problem given where we're headed. But again, at least at Analog Devices, we're actively researching, developing solutions that we believe will help with this challenge. So maybe just at this point, taking it back up a level, we believe that at scale, ubiquitous connected networks will need to be more energy efficient. They will need to achieve this carbon neutrality, but we also have to address all the other problems that I mentioned earlier. So maybe just kind of wrapping up a little bit here. So we, again, have a vision for this ubiquitous connectivity. Hopefully, I have given you some idea of what we mean by that, what we see as the positive outcomes, what we see as some of the challenges, and how we compartmentalize this. I mentioned, I've really emphasized this openness. We believe that's really important. We believe that creates an environment for innovation and expands the boundaries. I think Open RAN is a very good example of how the industry is moving in this direction, and we really applaud that. We are part of that ecosystem. And again, I would emphasize that sustainability is not simply a goal. We believe this is our responsibility as human beings to make sure that our technology innovations are actually for good and not causing more issues on the planet. So thank you. I want to close by maybe just showing an example here of how Analog Devices is working towards this goal of ubiquitous connectivity. We've really tried to embrace a broader innovation in these open ecosystems. And that's actually why we launched what we call ADI Catalyst. This is a facility actually in Limerick in Ireland, where we welcome our customers and our partners and actually even our competitors into an environment where we can collaborate. So to give one example, we actually have a 5G network test bed already in place here that we use to develop our products and to look at innovations that will be needed as we bring Open RAN to O-RAN to fruition. And I would just like to thank you for your time. And if you care to join us on this, you can come visit us on the Catalyst. So thank you very much for your time.